All right, let's go through these example problems. So the first one is saying that -5 is less than n. So I could, if I wanted to, I could rewrite that and say if -5 is less than n, that's the same thing as saying n is greater than -5. Right? If I flip the sides, I flip the sign as well, keeping the alligator eating the bigger side, in this case n. So if n is bigger than -5, okay, -5 gets an open sign. So down here you can see they do the open signs right on the line. That's fine. I tend to do them, I draw a little line up so you can see it, but either way is fine. But the key thing is that it is open, because it does not say -5 is not a solution to this inequality. If n were -5, it doesn't work, because it's supposed to be bigger than -5. And -5 isn't bigger than -5, it's equal to -5. And it is, so n is going to be bigger than -5, so it's all the numbers that go this way. So it's 7, it's 6, it's 5, and it's all the ones beyond this. It's 10, it's 100, it's 1,000, it's 1,000,000,000. And it's all the ones in between here, right? It's 4.5, it's 4.25, it's 4.1, it's any number you can imagine that is bigger than -5, and the way we can express all of them together is through this graph here. This shows us all the ones that are bigger than -5. Okay. Number 2 is -2 is less than or equal to v. So I could rewrite that if I wanted to as v is greater than or equal to -2. Once again, if I flip the sides, I flip the sign, because the v in this case is bigger than, so the alligator eats that side. And it's bigger than or equal to -2. So in this case, the -2, I fill that in because -2 is a solution that works. And it's greater than or equal to. So it's all of those numbers. So it's all the ones that are bigger than -2. Problems 3 and 4 are just like 1 and 2, except backwards. Instead of having an inequality and drawing a graph, it gives us a graph and wants us to draw the inequality. So for problem number 3, 0 is not a solution. You can see how that's open. So 0, so we'll say x does not equal 0, but x is all the numbers that are bigger than 0. So we would say x is greater than 0. And we don't put an equal sign here because this isn't filled in. So it would just be x is greater than 0. For this one here, we know that x does equal 5 because this solution is right here. And x is bigger than 5. So I put those two things together. X is greater than 5, and it's equal. So putting that together, we have x is greater than or equal to 5. Just like over here, we had x is greater than, but not equal to, 0. All right, for number 5, we have -4 is greater than -r. So I can rewrite that as just -r is less than -4. I just took this and flipped it around, and if I flip it around, I have to change the sign. But I don't want what -r is, I want what r is. So I could multiply this by -1, because a negative times a negative is going to get me a positive r, which is what I want. But if I multiply this the left side by -1, I have to multiply the right side by -1 as well. So -4 times -1 is just going to be 4. And instead of being less than, because I multiplied by a negative, when you multiply or divide by a negative, you flip the sign around. So instead of -r being less than -4, it's going to be r is greater than 4. And so it would be 4 that is open because 4 does not count. And R is greater than that. So it's all the numbers bigger than that like that. So that would be our graph. So 4 is less than negative b would be our next question here. I'm going to flip that around to say negative b is less than 4. And once again, I have negative b, so I have to multiply by negative 1. And if I do that side by negative 1, I do both sides by negative 1 for balance. So negative times a negative is a positive. That's why I multiplied by it in the first place. A positive times a negative, 4 times negative 1 would be, that would just be negative 4. And now I flip my sign. It was less than, so I flip it around to be greater than because I multiplied by a negative. And when you multiply or divide by a negative, you flip the sign. So b is greater than negative 4. So here's negative 4 right here. It's not equal to, so it's going to be open like that. And it is greater than, so it's all these numbers that are bigger than negative 4. Problems 7 and 8 are I have to isolate the variable. I have this one, 1 is less than or equal to x plus 14. So I'm going to flip that around to make that x plus 14 is greater than or equal to 1. Again, the alligator's eating this side here. So here I have the alligator eating this side here. That's the bigger part. And I want to isolate x, but x is x plus 14. The opposite of plus 14 is minus 14. So if I subtract negative 4, if I subtract 14 from the left side, I have to subtract 14 from the right side as well. So now those cancel. So on the left, I'm left with x. And on the right side, I have 1 minus 14, which would be negative 13. So I have x is greater than or equal to negative 13. So negative 13, which is right here in between the 14 and the 12, right there is negative 13. And I'm going to fill that in because it's greater than or equal to negative 13. Negative 13 is a solution, and x is all the numbers bigger than that, so it goes that way. This next one, number 8, I'm going to rewrite and get the p plus 1 and negative 19. And over here I have that the p plus 1 is the bigger side. It's opening up, the alligator's opening its mouth to make the p plus 1 bigger. So I do the same thing here. It opens up and it's greater than or equal to, because this is a less than or equal to. So I have to isolate my p, and it's p plus 1. So the opposite of plus 1 is minus 1. Subtract 1. And if I subtract 1 from this side, I have to subtract 1 from both sides. So p plus 1 minus 1, that cancels out. I'm left with just p, and that's greater than or equal to negative 19 minus 1. Well, that would just be negative 20. So p is greater than or equal to negative 20. So negative 20 it's greater than or equal to, so that gets filled in. That's a negative 20 is a solution. And it's all the things that are bigger than that. So it goes this way, greater than negative 20. Question number 9. I'm going to rewrite that one to get my just x on the left to make it easier. Negative 9x, and I have over here 108. And the negative 9x is the bigger part, right? It opens up into that. So I'm going to do the same thing here. I'm going to flip the sign around and make this negative 9x is greater than or equal to 108. And I have to isolate my variable x, but it's multiplied by negative 9. So I'm going to divide by negative 9. And of course, if I do that on this side, I do that on this side as well. So the negative 9's cancel, and on this side I'm left with x. And 108 divided by negative 9 a positive divided by a negative is a negative, and 108 divided by 9 would be 12. And now I have this sign right here, greater than or equal to, but because I divided by a negative, when you multiply or divide by a negative, you flip the sign around. So the greater than or equal to becomes a less than or equal to negative 12. So now I can graph it, the negative 12, it's equal to it. Negative 12 is a solution, so I, excuse me, so I take my circle and I fill it in because that is a solution. And x is all the numbers that are less than that as well. So going this way, less than negative 12 as well. Let's take a look at problem number 10. I have negative 7x and negative 77. And the negative 77 gets the big side. This is the bigger part right here. So I'm going to flip the sign around to make the alligator eat the bigger side, and it's greater than or equal to. And I don't want x. I want to isolate x. I don't want negative 7x's. I want just x. So the opposite of times negative 7 is to divide by negative 7. And of course, if I do that to one side, I have to do it to both sides because of balance. So the negative 7's cancel, and so I have x on this side. And on this side, I have negative 77 divided by negative 7. A negative divided by a negative is a positive, and 77 divided by 7 is just 11. And because I divided by a negative, I flip the sign. So less than or equal to becomes greater than or equal to. So it's going to be 11. And I fill that in because 11 is a solution because it's less than or equal to the 11, or sorry, greater than or equal to, so the 11 is a solution. And x is also all the numbers more than that. So going this way, going on forever here. All right, number 11. Once again, I'm just going to flip it around to get my variable on the other side. So I have 8 times x plus 1, and on this side I have 24, and the 8x plus 1, that's the bigger side. That's the one that the alligator is eating. So I'm going to put it like that. All right. The first thing I'm going to do is I'm going to divide. I have 8 times this whole thing, so I'm going to divide the whole thing by 8 to cancel those. But if I do that to one side, I have to do it to the other side as well. So over here, I'm just going to have x plus 1, and 24 divided by 8 is just 3. And again, it's just going to be greater than or equal to. Now I'm almost done. I have x plus 1. The opposite of plus 1 is minus 1. And if I do that to one side, I have to do it to both sides. So the plus 1's cancel, and I'm left with x, and x is greater than or equal to 3 minus 1 is 2. So 2 is going to be our key number, and it's greater than or equal to, so equal to 2 is a solution, and x is all the numbers that are greater than that as well, so it goes this way. Okay, our final one, we don't have to I'm not going to redo it. I'm not going to change the sides because the p is already over on the left. So negative 2, I'm just going to rewrite it. P plus, sorry, let me try that again. 9 plus p is less than or equal to 20. So I want to isolate this part in here. So I'm going to get rid of this part here by dividing by negative 2, because it's negative 2 times this whole thing. So if I divide by negative 2, those negative 2's will cancel. But of course, if I do it to one side of the equation, I have to do it to both sides of the equation. And so on the left, I'm going to have 9 plus p. On the right, I'm going to have 20 divided by negative 2. A positive divided by a negative is a negative, and 20 divided by 2 is 10. And because I divided by a negative 2, when you divide or multiply by a negative number, you flip the sine. Now I'm almost done. I have p plus 9. The opposite of plus 9 is to subtract 9. And if I do that from one side, I do that from both sides. 9 minus 9 goes away. On the left side, I just have p. And that's going to be greater than or equal to. On the right side, I have negative 10 minus 9. That would be negative 19. So negative 19 is going to be my key number. And it's greater than or equal to. So negative 19 is a solution. So I'm going to fill that in. And then p is all the numbers that are bigger than that as well. So it goes this way.